Welcome to Online Algebra 2. This is section 1-3, Algebraic Expressions. So our objective for this section is to evaluate algebraic expressions and to simplify algebraic expressions. And we can represent some mathematical phrases and real-world quantities using algebraic expressions. And probably the most useful thing that we would have to do with modeling an algebraic expression is turning words in some sort of word problem or even a basic problem like this, turning words to math. So let's give that a shot. Which algebraic expression models the word phrase 7 fewer than a number t? Well, fewer means we're going to get something lower, and it means that we are going to we want to take stuff away, which implies subtraction. So 7 fewer than a number t. This is where we're starting. So my answer is t minus 7. So another way to express that is t minus 7. 7 fewer than a number t. That's a pretty good one. But there's different words that represent different operations. Okay. This is also the difference between t and 7. So let's just go through a couple of these real quick with other types of words. T plus 7, 7 more than the number t, the sum of t and 7. This is negative 7 times t, the product of negative 7 and t, or negative 7 groups of t. I don't know, that's weird. But and then finally 7 minus t, or t less than a number 7. Let's try one that's a little more complicated in our guided problem. What is the expression that models the phrase 2 times the sum of a and b? So in this case, when you look at this, there's really two things going on. This times this thing. So it's 2, this multiplication, right? So it's 2 times a sum of a and b. So that gives me h. 2 times the sum of a and b. This is just a plus b, or the sum of a and b. This is 2 times a plus b, or the product of 2 and a plus b. But that's different than 2 times a total sum. So turning words to math, useful. And hopefully that's a skill that everybody already has a little bit of experience with. All right, so to model a situation with an algebraic expression, we're going to do the following 3 things. We're going to identify the action that suggests operations. We're going to define one or more variables to represent any unknowns, and then we're going to represent the actions using the variables and the operations. So let's look at this situation. You start with 20 bucks and you save $6 each week. What algebraic expression models the total amount that you save? So let's make a variable. What is the thing I don't know? Well, week. So let's say W equals weeks, number of weeks. Okay. So now we can, what are we trying to do? We're trying to get the amount of money over a certain number of time. Well, you're starting with 20 bucks and now you're saving $6 each week. So that would be $20 plus 6 times the number of weeks. Okay, so that's my algebraic expression with letters and numbers, right? And I don't have an equal sign, right? Because I don't know how much this actually equals. If I could plug in different amount of weeks to see how much money I would actually have in that current week. But this is an expression, it's not an equation. Oops. Right? You had $150, but you're spending $2 each day. What algebraic expression models this situation? So you start with $150 and you're spending it. You're not saving it, okay? So that's minus 2 times the number of weeks, okay? Because you're spending the money each day, okay? To evaluate an algebraic expression, substitute a number for each variable, then simplify with my order of operations. And hopefully you remember the order of operations is the order that you do different things in math. So the first thing you do first is perform operations within parentheses and work outward. If the expression involves a fraction, treat the numerator and the denominator as if they were enclosed in parentheses. Then we do exponents, then multiplication and division as they occur, working from left to right, and addition and subtraction. Okay? And you've probably seen this to help you remember PEMDAS. Parentheses, first one, exponent, multiplication, division, addition, subtraction. Just remember that multiplication is not more important than division. Okay? Multiplication and division are the same thing, so you just go from left to right. Addition and subtraction are the same thing, so you just go from left to right. Don't do addition first, right? So, let's evaluate an algebraic expression. So, we start with 7 times a plus 4 plus 3b minus 8, for a is negative 4 and b is 5. So we have 7 times negative 4 plus 4 plus 3 times 5 minus 8. All right, parentheses. First, here's an operation in parentheses. So negative 4 plus 4 is 0. No exponents. Next, we do multiplication from left to right. So that's 0 plus 15 minus 8. And now addition and subtraction. 0 doesn't do anything. And now we just get 7. Okay, let's try the next one. X over 2 plus y squared for x is equal to 1. So that becomes 1 half plus 1 half squared. Okay, so no parentheses. We do have an exponent. 1 half squared is square the top, square the bottom. That's 1/4. And now we have addition. And hopefully you remember that in order to add fractions, they need to have a common denominator. So this turns into 2/4 plus 1/4, which is 3/4. Okay. All the while following my order of operations. So let's take a look at this one. 2 times 6 squared minus, I'm going to put this in parentheses real quick, and I'm going to show you what I'm going to do with this. Y squared over 3. Okay, so parentheses come first. So I'm going to do these together, but before I do that, I have to do the, right, I have to do this subtraction, but the exponents come before the subtraction inside the parentheses. So I'm working inside the parentheses first, but I still have to follow the order of operations inside those parentheses. It turns to 36 minus negative 3 squared is 9/3. Okay? And now what the previous slide was saying is that these two are everything is over 3. Okay? So I'm going to do everything up top first. I'm going to simplify everything up top first, and then I'm going to divide by 3. So we have 36 minus 9, which is, so that's 2 times 27/3. So that is 54/3. And that gives me 18. Okay, so this was the trick right there, is realizing that you are squaring everything in y. Not, it's not that, right? It's not just squaring the 3, it's squaring the whole -3, because it does make a difference. All right, next, writing and evaluating an expression. So in football, touchdowns worth 6 points, extra point kick is worth 1, field goal worth 3. What algebraic expression models the total number of points that a football team scores in the game, assuming each scoring play is one of the 3. So no safeties and no 2-point conversions. So let's make some variables. T, it's going to be touchdown. Let's make K a kick, extra point. And let's make F a field goal. Now you don't have to use these particular letters. You can use anything you want. Normally we only put one letter as opposed to like a TD or field goal like this, but you can use any variable that you want. So let's make my expression. 6 points for a touchdown plus 3 points for a field goal plus any extra points that we put in there. Okay? Next part. Suppose a football team scores 3 touchdowns. So, 3 touchdowns, 2 extra points, and 4 field goals, 2 extra points. How many points did they score? Add these all up, and we get that they scored 32 points. Okay. Next, I got a problem. Basketball now. Teams score by making 2-point shots, 3-point shots, and 1-point free throws. So, what algebraic expression models the total number of points that a basketball team scores in a game? So, let's call this, and we can use any variable. So let's call that x, let's call that y, and free throws, let's call z. Okay, so let's use generic variables. So we're going to have 2 times x plus 3 times y, and then plus any of my 1-point free throws. So there's my expression. So it's going to have 10 2-point shots, 5 3-point shots, and 7 free throws. So, and we have 42. Okay, and 32 points is a pretty good score for a football team. 42 is not quite that good for a basketball game. It should get a little bit more than that. But anyway. Next, we have some vocabulary. An expression that is a number, a variable, or the product of a number and one variable is called a term. A coefficient is the numerical factor of the term. And a constant term is a term with no variables. We can add terms to form longer expressions, and we can really go as long as you want. And terms are always separated by addition. Okay, so all this stuff that is multiplied and divided together is one term. As soon as we have an addition or subtraction sign, we have our new term. Okay, so this is all one term, this is one term, and 6 is my constant term. And yes, again, it's addition of -6, so the constant is -6. The coefficients are the ones in the blue, 7 and -4. Okay, so what we can do with this is to simplify expressions, we can put like terms together. So these are terms that have the same variables raised to the same powers. Coefficients don't matter. That's what we're going to add together. But what you're really doing here when you take 3x squared and 5x squared, and I say, okay, this is something with like terms. You can combine these using uh, the distributive property, really, because what you're really doing is you're taking out the x squared, you're factoring it out, and now that these are just numbers, now I can add them together. And 3, 5, that's 8. So that's 8 times x squared. Now, we really don't ever do this step of factoring and then combining. We just say, okay, these are two like terms. I just add the coefficients together. These are two like terms. I just add the coefficients together. This one is not the same as anything else, so it doesn't get added to anything else. So the properties of simplifying an algebraic expression are all of these. So we can change subtraction to addition. That's the definition of subtraction, so we can use that property to help combine things. Same thing with division, right? Subtraction is just adding negative numbers. Division is just multiplying by a fraction. Okay, so a divided by b is the same thing as this fraction, a over b, and it's a times 1 over b. Multiplying by fractions is the same as division. Distributive property, for subtraction, this negative goes over here. For addition, this would just be a plus right there. When you multiply something by 0, it turns into 0. When you multiply something by -1, it turns into its opposite. You have to distribute the negative to both terms here. You have to distribute the negative to both terms there. And usually, while this is fine way to write this expression, sometimes to be fancy, we like to use the commutative property, making sure that the a stays negative, and we write it with the lead term as a positive. It looks a little bit cleaner. Depends on the situation for that. This is one whole term. It's negative times a times b. So you don't distribute a negative across one term, right? You only distribute negatives across addition or subtraction. So because this is all one term, only one of the two answers is negative, right? There's only one negative. If there was two, it would be a positive, like this. Negative and negative turn into a positive, opposite of an opposite. So all these properties should be things that seem sort of obvious and things that you can use to help simplify an expression. So when you're looking to simplify an expression, just focus on the like terms, okay? Just focus on the things, get rid of parentheses, and put anything that you can together, and look at what I have here. X squared, X squared. So that's a 7x squared minus 4x squared. That's a 3x squared. Y squared, Y squared. So that is a 5y squared. Now look, and then I look at the problem. Is there anything else that I could possibly do to make this any simpler? And the answer is no, right? I have one term with 3x squared, one term with 5x squared, y squared. Here, the trick is to get rid of the parentheses. So in the first expression, distribute the negative. And in the second expression, distribute the 2. Okay? Then combine the like terms. The k's turn into a minus k. And here, turn into a minus 9m. Let's try our guided problems. Combine the like terms. J squared, J squared. So I have a -4 plus a 1, so that's -3J squared. Ooh, not the same. And J is not the same as J squared. So this is as simple as you can make this particular expression. For part B, distribute the negative, distribute the 10, and then combine the like terms. So we have a -8 and a 10, so that's a 2a, and a minus 53b. To wrap up, you can take a look at these, and hopefully no problem with any of these expressions. And that was 1-3 algebraic expressions.